Hey everybody, Mr. Rogers here again today. So I have this really big project that I've been working on and I'd like your help. It's actually finishing the project that we started in the first video. So before we do that, I actually want to discuss again angles. So remember, an angle is created when two lines intersect. So this line and this line hit each other and create an angle. Now, we can measure that angle using a protractor. So, specifically I want to discuss three kinds of angles. Now, the first kind is the most familiar. We've talked about this one quite a bit. And it's a right angle, which a right angle measures 90 degrees. So I'm going to draw that here. This line and this line hit each other and they make 90 degrees. And I'm going to show 90 degrees. 90 degrees, remember, can be represented by this square. So that lets you know that these two lines intersect at 90 degrees. Now let's just take a look at that relationship with actual boards. So let's say we have a bottom board here, and then we have this board here. Now this board, we're going to put it in place. We want it to have a 90-degree relationship with this bottom board. So we're moving it into place, still not at 90 degrees. Still not at 90 degrees, still not at 90 degrees, and then finally, when it's perfectly straight up vertical, and this bottom board is perfectly horizontal, they have a 90-degree relationship. Now, here's the tricky thing about 90-degree relationships. Again, it's how these two boards hit each other. So even if I go like this, the lines still have a 90-degree relationship to each other. If I go like this, the way that these two lines intersect hasn't changed. They still intersect at 90 degrees. Now, there's a couple of different ways to make a 90-degree relationship using blocks or using wood. Now this way is just a flat edge coming into contact with another flat edge, 90 degrees. Now there's another way we call it a picture frame, where you can have two 45-degree angles. Now check this out. 45 plus 45 equals 5 plus 5 is 10, so put the 0, carry the 1 up. 4 plus 4 is 8, plus the 1 is 9, so 90. So not only do we have, I'm just going to show you this again. Not only do we have our 90-degree angle when we have a flat edge that hits a flat edge, we also have a 90-degree angle when a 45-degree angle and a 45-degree angle come together. So that there is also a 90-degree angle. And you can look at that in a lot of different ways. You can shift it, but still these two blocks cut to 45 degrees come together to make a 90-degree right angle. The next kind of angle that I want to talk about is called, now we're going to learn some new vocabulary, it's called an acute angle. So an acute angle is basically any angle that measures less than 90 degrees. So here we have our 90-degree relationship. I'll put the little square here. So that's 90 degrees. That would be a right angle. But an acute angle, here, let me get a better marker, is any degree measurement. So if I had this here, 90 is straight up. Any line that is, say, this would be 30, this would be 50, and this would be 70. And notice I'm making two dots so that I can connect the two. So I need, in order to make a line, or a straight line, I need to have two dots. So this one I said was 30. This one I said was 50. And let me measure this one again. I'm not sure I've already lost track. I said this one is 70. So here you have our 90-degree measurement, which would be a right angle, but then each of these angles in blue represents an acute angle. This is 30 degrees. This is 50 degrees. And this is 70 degrees. Now let's say I draw another one. Let's say, let's do 60 degrees, which would be roughly right here. That's still an acute angle because it's less than 90. Now, let's show an example. Okay, so we have our horizontal board again. Now remember, here, let me spin this around. This is that's our right angle. That's our 90-degree relationship, right? Now let's shift this around a little bit. We now have a board that I've cut to 45 degrees. So instead of going straight up like our 90-degree angle, it's less than 90 degrees. So now it comes up here at an acute angle. So this angle right here is a 45-degree angle, which is an acute angle. Now, here's the interesting thing, and this leads us into our other kind of angle. When you have two lines, this line that intersects with this line, and this line, notice how this line continues to move. It continues to go beyond this line. What happens is you create two angles. You create an acute angle, which is less than 90 degrees. So here's 90. This is an acute angle, less than 90. And then look at this angle, the other angle that's created. Not only does it go up, 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 hits 90, but it continues on. And so this is called an obtuse angle. So an obtuse angle, so check this out. We have our 90-degree relationship here. This line and this line intersect at 90 degrees to make a right angle. And then an obtuse angle is a line that measures more than 90 degrees. So up, 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 you hit 90, just like with the boards, and then you continue on. So let's say we go to 120. So I'll erase here now so that you can see. This angle here measures 120 degrees. Or I hope it does. I haven't measured it with the protractor yet, but it measures 120 degrees, so it's gone up beyond 90 and to 120. Now, like I showed you with the boards, let's say that this line continues on. So this line and this line intersect. An obtuse angle that's 120 degrees has been created, but also an acute angle has been created on the other side, an angle that is not 90 degrees. It only goes up, but it doesn't go all the way up to 90. So this, remember, on a straight line working up, you're only working with 180 degrees of measurements. So here we have 120 degrees in our obtuse angle, and then in our acute angle that's created, we have the other 60. So essentially, it goes up and all the way over, and this entire rainbow-like mark is 180 degrees. In the first video, we talked about a shelving unit that I've been working on. So here's what I want to do, and I've already made the cuts, but I want to discuss why I made the cuts that I made. So let's look at a right angle. Now, I'm going to put the little square there that lets you know that this is a right angle. And so what I've created is I've made a shelving unit that we're going to display artwork on. So we're basically looking, it'll make more sense once you actually see the structure, but imagine we're looking down on it, and artwork is hung here, 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 and here. So basically what will happen is you'll walk in, you'll look at the art, walk in, look at the art, 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 and then exit. And people can do that. You can do that in a single file, or you can look over somebody's shoulder. there's plenty of space in this type of setup, right? We have a big open space here where people can stand and look and talk. Now, I didn't want to make it exactly like this because this is very similar to just hanging paintings on a wall, right? This could be the walls of a building or the walls of your house. So I wanted to be a little more creative than that. Now, I thought about, well, maybe we could use an acute angle. So this is an acute angle, but the art would be here, 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 and here. Now, only problem with this is, look, we had a lot of space here. When we had the right angle, we had a lot of space here where people could look at the artwork, stand and talk, but now we've limited that space here in the middle. So I walk in, I look at the art, I look at the art, I look at the art, and now at that same time, let's say, at that same time, Eliza, you walk in behind me, you look at the art, right? And then I turn around and I bump into you and I fall down, right? And then at that same time, Tanner walks in, and he, oh, sorry, Mr. Rogers, I didn't even see you there. He steps on my hand, and I'm like, ah. And then at that same time, let's say Mason just happens to be right in one of his infamous guitar slides, and he slides in, and he's like, oh, I'm so sorry, Mr. Rogers, and he knees me in the side, and oh, I think maybe I broke a rib. So look, and all of a sudden, it's just a huge pile of people that have fallen on me because there's no space, right? There's no way, once I'm in, there's no way for me to get out, and if I fall down, I get trampled. So this isn't necessarily the best type of setup here. This is an acute, remember, this is an acute angle, here to here, because it measures less than 90. So we start here at our 0 degree measurement, we go up, we go up, we go up, we choose, this maybe is a 30 degree right here, and that's where we stop. We didn't go all the way to 90, which makes it an acute angle. Now, what I decided to do, I decided to make an obtuse angle. So what I want to do is this. So it's an obtuse angle. So you start at 0, you go up, 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 you reach 90, but you keep going beyond to 120. Now, here's the artwork, 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 artwork. So now, remember, in the right angle arrangement, we had a lot of space, but here we have even more. Look, I can come in, look at the art, look at the art, look at the art, continue on, and while I'm doing that, other people can be looking over my shoulder, they can be standing here talking, there's even room for Mason to do his guitar slide, there's a ton of space. So that's what I've done. I've cut a 60-degree angle, and by using that 60-degree angle in a certain way, which I'll show you, I was able to create a 120-degree angle. So imagine this is one of our boards. I cut this board to measure 60 degrees, and by doing that, I created, like what we discussed just a minute ago, I created the other angle, the 120 degrees, to make the full 180. So on this side, I have the obtuse angle, the 120, and on this side I have the acute angle. So let's take a look and see what that looks like. Now, so here on the floor, I have this long board, about 8 feet long, travels. Now, here, I've cut both of these boards to be 60 degrees. Now, this board is actually going to meet with one of the shelving pieces. So that's measured at 60 degrees because it's going to catch it at an angle. Now, this one, let's just take a look at this. I'm going to pull it back just a little bit further so you can see. So let's have a look at this relationship here. So this is going to be the shelving unit, or part of it. I haven't been able to get to the store. Eventually I'll use a pine board, but for now this is going to work. So here I've cut this board at 60 degrees. So this is a 60-degree cut. I used a chop saw to do it. Now here you can see this angle is less than 90 degrees. 90 degrees would be more vertical, right? So this angle is 60 degrees. It's an acute angle. But remember, because this board continues on, when I create that acute angle, I also create an obtuse angle here, and this is the one that we wanted. This is the 120 degree angle that gives us a lot of space in the middle for people to walk and to stand and to talk. Okay? So let's take a look at what this looks like from high above. Hey everybody, this isn't the finished product, but I'm getting pretty close. I still want to stain the wood, and I still want to use a piece of pine board for the shelf. But you can see here that the inside angle, like I said, it's not an acute angle, and it's not a right angle. It's actually an obtuse angle. Here, we'll follow it down, and you'll see that it opens up. Now this, like I said, this isn't perfect right now because I'm going to use an L bracket and I'm going to use a pine board, but this is cut to 60 degrees and it's turned so that it creates that obtuse angle, which is 120 degrees. So if this board here were to continue on, it would create an acute angle here, 60 degrees, and an obtuse angle, which it does right here, 120 degrees. And then it continues on down this way to the final structure. So I'll just step back and kind of give you an idea of what I mean. Here, someone will come in, canvases with artwork will be positioned on the shelves. You'll be able to walk in, you'll look, you'll follow it through, and then you'll walk out the other side, while at the same time there's going to be plenty of room here where in the middle space where people can look over your shoulder, can stand and talk, and nobody's going to get boxed in. Like I said, like with the acute angle, if it were a confined space, somebody would get to this point and they'd be looking at the artwork and then they'd turn and they'd have no way out. So in this case, we're not going to have that. We're not going to have that issue. In fact, we have so much space that even Mr. Rogers can do a sliding air guitar.